The mesopelagic zone is usually defined as the depths in the water column between about 200 and 1,000 meters. It's also referred to as a twilight zone because this area is generally defined by low light levels. So it's the expanse of habitat occurring below the upper euphotic zone. This area is home to a diverse assemblage of organisms that play a really important role both as prey to many species more familiar to us in the surface and also as exporters of carbon from the surface down to deeper depths. So they also play a role in climate regulation. We think of many of the mesopelagic fish species inhabiting these depths as otherworldly or alien, but in fact, they're very interconnected to the rest of the ocean ecosystem, especially through their vertical diel migration, which occurs most evenings, where a lot of organisms actually traverse the water column up into the surface to feed before descending back down during the daytime. And this is considered the largest animal migration on Earth. Off the US West Coast, where I'm currently based, we experienced a large-scale marine heat wave, most pronounced in our region in the Central California current area between 2015 and 2016. And this large marine heat wave had dramatic effects on the epipelagic communities, so those organisms living in the upper surface layer, from range distribution changes to changes in abundance for a lot of species. But it was less clear how this huge event, which was primarily considered to be a surface warming event, affected those organisms living just below the surface in the mesopelagic zone. So we were really curious to see whether or not changes in oceanographic conditions at the surface could still have a profound effect on those organisms living just below it. To evaluate how the large marine heat wave event off the US West Coast affected mesopelagic fish populations, we used acoustic data that was collected as part of an annual NOAA survey to determine how the vertical distribution or the position of mesopelagic fish within the water column changed during this warm period. We used data from 2013 through 2018 to capture those conditions prior to, during, and following the large marine heat wave event. And we found that during the two strongest years of the heat wave, 2015 and 2016, the vertical distribution of mesopelagic fish in the water column descended significantly deeper than in any of the other years of our survey. Compared to 2013, which predated the heat wave in our region and was defined as a strong upwelling year, mesopelagic fish descended over 100 meters deeper during both 2015 and 2016. And it followed a parabolic shape. So even after the heat wave by 2018, we still hadn't seen a return to pre-heat wave levels in terms of the vertical position occupied in the water column by mesopelagic fish. In addition to the acoustics data that we used to evaluate the vertical distribution of mesopelagic fish, we also collected data on the ocean conditions that were present during this time. And when we link those together, what we think is happening is that there was a compression of upwelling habitat, upwelling being the vertical transport of deeper nutrient-rich waters to the surface, which fuels primary productivity in our region. And because upwelling habitat was compressed closer to shore during the large marine heat wave event, we think that there was more light because there was less primary productivity in those upper layers penetrating to mesopelagic depths, and that mesopelagic fish responded to that by descending deeper to evade visual predators during this time. The broader impacts of this work, there's a few. What mesopelagic fish are important to the California current ecosystem and globally as well, as providing prey for many things that we consume, such as swordfish and tunas and rockfish. And they're also important transporting carbon from the surface to depth. So they may be playing an important role in global climate regulation. Any change to their vertical distribution, which changes their availability to predators or their ability to export carbon into the water column, could have profound effects to the rest of the ocean ecosystem. As the global climate continues to warm, heat waves are predicted to become more intense and more prevalent, at least in our area. And so the incidence of mesopelagic fish vertical distribution deepening may increase, which may make it more challenging for predators to consume them and may change those carbon export dynamics. I think the real conclusion from our study is that even though mesopelagic organisms are inhabiting these depths below the euphotic zone, which we think of generally as being more stable environments, they're still impacted by what's happening at the surface. And that may be important with continued global climate change. And I think the real takeaway for us too is that we should consider mesopelagic organisms when we think about the broader ocean ecosystem and how it may be changing in a warmer future.